you so much. Is the mic on? Yes, now it is. Okay. So I'm just really impressed with Canonical here because they gave me a clicker that has next on the green button, so the stupid German doesn't mess it up. And I haven't had enough coffee, I guess, myself. So, yes, as Andrea said, just to quickly introduce myself, my name is Christian Holsing. I work for Intel, and I cover open source vendors there. And I would just love to give you a quick overview of an open source initiative that Intel initiated called OPEA, the Open Platform for Enterprise AI. Okay, the next button works. Acclaim success here. Wonderful. So the challenge that we see, and I'm sorry for that, although I'm an open source guy myself, I'm taking a little bit an enterprise view on this whole topic here, because ultimately we're all here to drive some revenue being paid, and unfortunately that involves pleasing customers. So from a GenAI topic perspective, there's actually an emerging conflict that we see. If you look at what open source is doing, what the whole AI ecosystem is doing, what model providers are doing, it's incredibly fast. But on the other hand side, we see companies and enterprises actually adopting changes really slow. And that's a problem that we see, that I also see in my group, with my colleagues, that basically large corporations would love to use GenAI more and more, but they actually struggle to figure out how they can move it into production, stabilize it, even comply with regulations that are enforced on them. And I basically had one that Intel enforced on me. I found a glitch in the presentation about 20 minutes ago and thought I'd rather update that. But when I thought, oh, I have my USB key, I just copy it there. I got a lovely message from Intel IT saying you're not allowed to copy it on a USB key. You can only read. So let's not discuss that from a security perspective, but from a virus perspective, but whatever. So these things are out there, they are reality in corporations, and we all as an ecosystem, as a community, need to figure out how we basically address that. Second aspect, second problem to this whole topic is the question of enterprise data today is mostly stored locally. There is still the move into the cloud, no doubt for that. But there are IP concerns. For example, there are local data centers. And again, this is kind of a different view on the problem I described initially of, how can slow-moving enterprises or kind of slow-moving enterprises start to adopt faster, I'm not saying with lightning speed, but faster, basically AI models and AI capabilities. And I think we have a lot of the building parts as an open source community with Kubernetes, containerization, and those kind of models in place. Open source, closed source, a mixture of running these workloads. But there's still some work to do to actually be able to deliver it and implement it in enterprises. So a few challenges, I spoke about them and made a little bit of fun about them already from an enterprise perspective, but really, if I'm moving open source, if I'm moving a commercial application into an enterprise and try to deploy it there, I have to comply with a lot of rules. That's starting with validated stacks. So I'm coming out of a collaboration email system background, and I can just tell you that some of our customers were testing even an update to an email client for about a year in production before they would even move and roll that out, which really conflicts with the speed that AI represents today. So validated software stacks is a problem. Security and manageability is a big problem. Right, because that was also a recent experience I had. I took the family to the US for vacation. Our flight got canceled. So as a German, I flew Lufthansa, and I was interacting with their app, which was basically a chatbot using AI in the background. right? So there is a different requirement. From an open source perspective, from an end user perspective, we're probably all accepting that the service is down and we have to wait an hour or two. But if you put yourself into the shoes of using AI in a money-generating environment, that's unacceptable because it's really crappy customer experience. If you're stranded at an airport and you can't find anybody and there is a queue of 150 people in front of you before you're able to talk to a human. So just a couple of things. Enterprise grade is the same thing. There are not infinitive resources, even if all the cloud service providers give us almost infinitive resources. There is a limited resources for sure, which is money. So there really is a pressure on this whole topic, on the whole deployment, and the answer, I think, that we're coming up from an open source ecosystem perspective in a lot of times is defining standards, defining a way to really standardize the different components and define a reference architecture, so to say, on how to start driving things into production. So ecosystem complexity, I think I touched most of them already. It's just a more comprehensive list than the one before. Let me just touch one point out of this, which is important, integrating with enterprise systems. Right? As I said before, the data needs to come from somewhere, and that needs to be integrated. This is also why very often companies are just not taking their model and move it to the public cloud or train a model in the public cloud, because that means I have to expose data. So I could just do a little detour to confidential computing, which is one of the nice projects that we're doing from an Intel perspective right now with Canonical. So there are answers that are being worked on, but still it is a challenge. And the question of how do I bridge all these gaps, how do I bridge all these different processes and rules is, in the end, what we're trying to address with OPEA. Also, obviously, the technical complexity. I hope that most of you have heard about the term RAG et al., and maybe I should explain that a little bit more. So in the past, I think AI meant I'm an enterprise or I'm an end user. I take data and I start training a model. That was working for a while, but if you followed the press recently, so there was, I think, OpenAI, that went to the US government and said, we want to do a US-based AI data center. We need 3 nuclear power plants to just power that. So where I'm going with this is training a model with billions of parameters is cost and time intensive. And what we see happening right now is a shift in the market that especially enterprises rely on pre-trained models instead of going out, invest in infrastructure, and start to train model. So AI breaks right now into two different disciplines, if you want to say it like that. One is training of models, which is, as I said, super compute intense. Just to give you kind of an idea, and you find this on public sources, if you go and buy a server with 8 GPU cards in it, that's basically almost blowing your data center, because we're talking about 10 to 15 kilowatt hours of power consumptions. And we've seen this in the German data center with one of our customers. One of their racks is specified with 8 kilowatts. So it's an interesting problem here, just from a compute perspective for on-premise with training. That's why a lot of people just move to, I use models that somebody else has trained, like Llama from a meta perspective, and I deploy that for my AI use cases. Now the question comes, how do I make that context sensitive? Right? Because your context, your enterprise, has different data. And a friend of mine who's doing AI project explained it to me in a way to say, the model is a multi-dimensional room, if you look at it that way. And when you send a query into it, it randomly starts somewhere. So the quality of your answer might be good or bad. You don't know. So the context of your query becomes important. Now, this is what RAG is introducing. Instead of retraining a model, basically what you do in the RAG stands for Retrieval Augmented Generation. What RAG as a concept is doing, you basically take data, it could be a PDF, it could be an image, something, you parse that and move it into a vector database. So you probably have heard that concept before, the discussion about vector databases, which are rising right now. So it's a lot driven through the RAG architecture. And these vector databases basically store ultimately the data, the weighting that you put into it. And when you do a query, how the RAG model works is you basically say, I'm taking a whatever, for the sake of the argument, I'm taking a PDF that I want to ask the model questions on. So I'm taking the PDF, I turn it into so-called embeddings, store them in the vector database, and then these embeddings are moved into the LLM, so that basically you're not randomly starting anywhere, but based on these embeddings that you attach to the query, you start at a dedicated point where the context is very close to basically what your query is about. Now, you've heard I spoke quite a while explaining this concept, and if you look at the different components that you see on the architecture, it's becoming pretty complicated pretty quickly. Going back to where I started on this, if you go out to a customer and just for the sake of the argument, I live close to Heidelberg. There is a small enterprise software vendor called SAP very close by. So if you go and have a discussion with SAP about an architecture like this, there are a lot of people that have a say on this and have concerns. And how do you make this enterprise stable? How do I scale this out? And it's becoming pretty complicated here very, very quickly. You know, because again, it's above the vector database. There are tools to embed the data from the vector database back in. There are tools to parse data. So it's all open source. That's the good thing, or mostly open source. There's still closed source in it. But the model, the reference architecture becomes pretty complicated. So now going to OPEA, as I said before, this is an initiative Intel started, open platform for enterprise AI, which is open source. I think it's accepted by the Linux Foundation already. But it's really, as I said before, an approach to simplify RAG models and standardize them, and have the open source ecosystem starting to contribute to it. Intel is contributing heavily into it, others do as well, and basically package it up at some point and be able to go out to an enterprise and say, instead of you're doing a research for half a year, 3/4 of a year, here are prepackaged examples that you can take, deploy, and take forward, getting experience on it. So OPEA really becomes a framework of composable building blocks. So the components I had on the chart before are defined. So these building blocks can be pulled, they can be combined, they can be replaced, you know, because somebody has corporate rules of using a different vector database. So the whole idea is I'm able to just replace my vector database with the one that's favorite of mine, or use a different LLM for it. It becomes a blueprint. You know, how does the whole RAG process work? And where can I start to basically get something into production, into production for a POC level? That's part of it, and also the assessment from an enterprise perspective, because ultimately you need to scale. And back to my Lufthansa example, you know, at that day when my flight got canceled, it was probably a couple of thousand people that were interacting with their chatbot. And back to the crappy customer experience, right? If you get a slow response, then you're impacting your end customer. So it's also about performance, trustworthiness, enterprise readiness, really working with companies like Canonical here to bring it to that level and advance it to a point that you can easily move out of a POC into production readiness. Very high level, the way the project looks at it, and I referenced containers before. So the OPEA architecture is a set of microservices, so containers, that make up a solution, including the LLM data prep, vector database, and so on. Everything becomes bundled into a mega service. So think about this as a use case. And an API entry point into it, because most of the work that's being done here on OPEA is API-driven. So people write their own front end quickly, do a REST call into the OPEA platform, and get their answer. Which then is starting to break it down. I mean, there's still the same complexity that you've seen on an earlier chart in terms of microservices that can vary and that are plumbed together, right? But there are building blocks through OPEA where you can start using, the model embedding containers, and then you just really, from an end user perspective or from a deployment perspective, start to replace the parts that don't meet your need for whatever reason, regulatory requirements, compliance, whatever. So that's really the overarching idea of the initiative and the project here. And here's a list of the initial services. This is all on GitHub, by the way. So it's completely open. You can basically go out, see what the development status is. Right now, there's a lot of contribution from Intel as we've started the project, but we see other companies starting to contribute more and more. So there is the reference architecture, the reference services. You can go on GitHub openly, download it, play with it. Here's a list of the services that are actually available and are pre-packaged at this point for your reference. And as we're talking about an enterprise deployment, it really comes back to the question of how does the data center stack look like ultimately, and how can we go to a customer, whatever your favorite customer is, and have an offering together with Canonical here to say, here's the foundation, here's a secure operating system, here's a secure Kubernetes management engine, container runtime, all the APIs are managed, and you put OPEA in a containerized version on top. So that's work that's going on behind the scenes that we're collaborating on. And as I said initially, if we look at enterprises, there is companies that want everything on premise. There's companies that embrace the cloud. So we just had this discussion internally on Thursday in a team meeting of some customers just have the policies of, I just want to move everything to the cloud. I mean, AWS customer, everything has to run there. That's my policy. Others are saying, no, this has to run on premise because there's confidential data. There might be legal contracts that are feeding into the rack. And from that perspective, a company might just want to keep that on premise. And of course, you could go hybrid to some extent, and then the question for us becomes, how do we architecture this? How do we secure communication? How do we manage latencies? All these kind of funny things that come out. So this is kind of a snapshot of the project. Importantly, you see Canonical on there as well. So Canonical joined the OPEA project recently. We're working very closely with Andrea, for example, and team here to drive it, and it's an interesting and growing ecosystem. So this is already a couple of weeks old, but there is a lot of discussions. There is on opea.org or opea.dev, you can basically also start joining the groups. So there are regular meetups, as you would expect from a typical open source project. feel free to take a closer look. And hackathons are happening right now. So all of that is public. So here's actually the slide that I noticed was messed up before. What we're doing from an Intel perspective right now is taking this one step forward. And in the next few weeks, there will be productized examples. The examples are already out of GitHub. We're working on productizing them. And one of them is a Q&A chatbot. So this is basically an end-to-end solution that you could just download, play with on potentially a local machine for not good response times. That should just do the trick. If you want better response times, then you could take this Q&A, and it's really a complete solution where you can just take enterprise data, PDF, whatever, feed it in there, and then run questions using an LLM of your choice. So this architecture is out there. The solution, again, will be stabilized. That's work, and there will be definitely more of these solutions actually coming out in the next couple of months. So that's where Intel is focused, besides the contribution upstream to the project. So this is the architecture. No surprise here. If you looked at it before, there is a user interface even that we provide as an entry point. But it's all the building blocks that we talked about before. Just as I can download it, I can deploy it, it works, and then I can start from there and adjust basically the different components based on my own needs or your customer's needs. Let me talk 1 or 2 minutes about Intel and open source. This is, I think, since I joined Intel, one of the best kept secrets. We are, for the last couple of years, #1 contributor to the Linux kernel. Intel has about 10,000 to 15,000 software developers that contribute to open source, and it's really across the board. I mean, it's fairly obvious when I'm saying, okay, we do kernel work, that we basically provide drivers to Intel GPUs and so on, the latest CPUs, but it's also really general work that we're doing, key kernel contributions, Kubernetes. If you think about PyTorch, TensorFlow, for example, as the runtimes that we're using in the AI/ML space, we're also very, very active. And Andrea has a nice project out called DSS, Data Science Stack, where basically the Intel optimizations for PyTorch are just prepackaged. So that's a lot of work that we're doing behind the scenes that I just want to mention, but that's a company strategy from an Intel side, wherever possible, going open source and contributing things to the Linux Foundation and basically helping you guys out from an open source ecosystem to really advance things. So no Intel presentation without a roadmap. So basically, just quickly for your reference, this is the OPEA roadmap as it looks like today. So really the next steps is the models, the examples that we want to bring out. That should happen in the next couple of weeks and months. And then really advancing the RAC architecture, advancing the whole solution, and as I said, making it more enterprise ready. That's still some work to do here, but I think we're on the way to go there. And with that, I'm landing on time. I have 6 seconds left, so.
Exactly. Thank you, Christian. We have time for one question. Let's see who's running first to the mic. Don't be shy, don't be shy.
They are.
They are shy. Okay, then I'm going to ask you something. When it comes to adopting open source in enterprises for AI/ML use cases, there's obviously a lot of excitement, but there are still challenges. What do you think is the biggest challenge, or what have you seen as being the biggest challenge?
I think one of the biggest challenge in general is just the discrepancy between the speed of open source and the readiness for an enterprise to adopt. I mean, I spoke about Kubernetes in a former job. We were trying to deploy a Kubernetes-based stack, and I think all of you know that Kubernetes has quarterly release updates. The customer, it took them about half a year to just test the next Kubernetes release, which means they would get 3 months of a window to use that, and then they had to run over. So there is a challenge, and I'm not saying that only the open source developers can and have to solve that. It's also the enterprises getting there. But I think really coming to a point of stabilizing it, shortening the test cycles, building trust in both directions is important, right? And I think it's very hard from an open source developer perspective to realize the challenges that enterprises have, because if things are down, just another example, I myself worked in the SAP space for a very long time, and when an SAP system was down at a retailer, they are losing millions of dollars a minute. So you're not messing around with that. And there are really different requirements, and if we can solve them together, then I think we get open source a really long way into the enterprise.
Thank you, Christian. If you want to talk further with Christian, or you can find him around probably.
Or Helena for OPEA. So find us. We have an OpenVino, sorry. Excuse me.
Thank you.